Example 3, analyze the graph below. So we're going to look at this picture of this graph. Again, the arrowheads will add them in because that graph would continue. State the zeros in their multiplicity. Zeros, remember, are x-intercepts. So where it crosses the x-axis, so x equals -5, -1, and 4. The graph crosses right through at -5 and -1, so we would say that that has multiplicity of 1. It bounces off at 4, so we call that a double root, so it would have multiplicity of 2. Okay, so remember that's because it bounces off the x-axis there. B, determine the x-intercept and the factors of the function with the least possible degree. Again, we already have the x-intercepts because those are the roots, so we can list those again. The factors would be if we write these as binomial. So factors would be x plus 5, x plus 1, x minus 4. Now, because this is multiplicity of 2, that means that this would have been squared. So if there's a squared, x equals 4 would have occurred twice, and that's what the graph would look like. C, state the intervals where the function is positive and the intervals where it's negative. Positive means above x-axis. Negative means below x-axis. So for the positive one, we're going to look at this part of the graph right here. So how do we state that? That's between the interval -5 to -0. So -5 is less than x is less than -1. So x is greater than -5, but at the same time less than -1. For the -1, we've got this part branched down here. So x is less than -5, or here from -1 to 4, because it doesn't include 4, it's below, so we could say between -1 and 4. So -1 is less than x is less than 4, and greater than or equal to, no, sorry, not equal to, greater than 4, because it does not include the x-intercept. Now, another way we could look at this part, we could say that x is actually everything less than -1 except for just that 1.4. So instead of writing out two intervals, you could take this part of the graph and describe it as x is greater than -1, where x cannot equal 4. This part would also still be included in the answer in that case. Determine the least possible degree. That's basically just saying what is the degree. So I know that it crosses 3 times that this one bounces. So we know that this is quartic. 1, 2, 3 turns might be helpful. So we would call this degree 4. The end behavior, falls left, falls right. That also helps me determine that it's an even function, which helps me realize the degree must be an even number. So that makes sense for degree 4 as well.